All right, so we're going to shift focus a little bit. We're going to talk about the exciting world of automation. Automation. So, we heard about Tim talking about enterprise testing. You heard Aspat and Ankur talk about security and how great it would be to bring down someone's computer. Shift focus a little bit to automation. So, typically what happens in an organization is automation is considered to be an afterthought. People do the testing, and then, yeah, it'll be great if I can automate it, and the result of that is not enough automation, which means they can't run enough tests in time. So we at Spirent are trying to change the focus. So we like to consider or put forward the theory that automation should be more of a byproduct of testing as opposed to actually doing it separately. And we have this whole line of products from Spirent called iTest, which are going to help people produce more automation. The flagship product is called iTest Enterprise, which is more of an authoring orchestration tool, which I had the privilege of showing everyone last NFD. So today I'm going to shift focus a little bit again and talk to you about this terrific new product that we introduced very, very recently, last month as a matter of fact, called the iTest Lab Optimizer. And it's going to solve all your lab optimization automation needs, or at least that's what we hope anyway. So before that, I'm going to kick off with a quote. So the quote goes, the first rule for any technology used in a business is that automation applied to an efficient operation will obviously magnify the efficiency. And you can probably guess how this quote is going to end. If you apply the automation to an inefficient operation, it's going to magnify the inefficiency. Okay. Can anyone guess who made this quote? See a lot of Apple MacBook laptops here, so it's no one from Apple. It's probably someone you hate, don't think very much about. Hint, hint.
Gates?
Yeah.
Gates?
It's interesting you said that. So.
Respect your enemy.
Sorry?
You got to respect your enemy.
Got to respect your enemy, exactly. Yeah. Actually, Jobs didn't have that many bad things to say about Gates in his book, so it was really surprising. So anyway, so if you look at this, wow, the resolution is really bad. If you look at this quote, right, so it's all about minimizing what you're automating because you want to minimize the inefficiency. And one of the most inefficient places, if you look at in today's networking testing world, that's trying to automate is the lab, right? Because the lab is full of a lot of things that many people don't even know what exists in it. So how many of you, wow, it's really bad. Raise your hand if your lab looks like this, right? You don't have that. No, not at all, not at all, right? So note to everyone, this product is not about cabling correctly. It's the recognition of the fact that that's what the lab exists in today's world. So how best do we see what's in the lab? How best do we cable it? How best do we automate the cabling? How best do we bring up the visibility of what's in the lab? And that's what this product is targeted all towards. So essentially, this product is trying to answer 3 or 4 questions. Right? First is, who's using my lab? Right? I have so many testers running around. I have a team in Bangalore. I have a team in San Jose. Who's actually using my lab? And when are they using it? Is it used all the time? Is it used only a subset of the time? How do I know that information? Okay. What exactly is in my lab? I go in there and I see the lab manager gives me the budget for $3 million for my lab. How do I know what's exactly in my lab? Do I have a good inventory management system? Can I figure out what do I need to phase out? Can I figure out what do I need to upgrade? How do I make those decisions? Okay. How are all the resources in my lab connected? Right? How many of you here know what a layer 1 switch is? Yeah, everyone. Good. That's what I want to see. So a layer 1 switch is, God's greatest gift since sliced white bread to a live manager. It allows them to connect different resources at different times, right? And that sort of prevents someone going in to have to recable it manually. Okay? But once you do go in, set up a layer 1 switch, 32 ports, how do you know what all they're connected? And if you do have to reconnect them, remap them, how quickly can you do that? More important, do you know what's connected to what port, when you want to do the recabling, right? Again, not enough visibility. And then the whole point of the lab is to do test executions. So can you tell what test executions are going to happen in my lab or about to happen in my lab? How many times, or can you prevent lab overlap? If one tester wants to use a test bed, can you prevent him from using the same test bed when some other tester is using it? Can you have a reservation system in place? So that's the kind of challenges that we see in today's lab, and that's the kind of challenges this product is supposed to fix. This is our first generation of the product. It's the 1.0 release. We made it in September, and we'll be adding to it very, very aggressively. In fact, we have a very aggressive schedule with a 1.1 and a 1.2 release coming out very shortly. And there's a lot of good things available in this product. And if I had time, like maybe 3 hours, I would walk you through all of them. But since I don't, I'm going to keep it very limited, very focused, and talk to you about some of the great things that we've added to this product that makes us a little better than our competition. Okay? So what this product gets to the table today is the capability of reserving and scheduling our resources in test beds. It's a classic reservation system. It has an Outlook-like calendar where you can drag and drop your resources, block test beds, make reservations so that testers are not overstepping on each other. You have this thing called topologies, right? Both physical topologies, what's actually in my lab, and logical topologies, which is the test scenario that you're doing, which is very different from what's actually in the lab because testing scenario is very specific. So this product gives you the capability of creating both physical and logical topologies, and I'll show you a demo of that, and also the capability of dynamically resolving your logical topology at one time. So if you're a tester and your test bed says, I need 2 Cisco routers, should you need to know how the routers are connected in the lab? You shouldn't. All you need to specify is, here's my routers, they connect them, now go activate them. So what you want is some magical system, an automagical way of figuring out how are all those routers connected through a layer 1 switch. If they are connected, map the correct ports together to activate them. Yeah. Right? And you want someone to do that for you. Well, great news, this product does that, and I'll show you a demo of how that can do that. I talked about utilization and figuring out what's in your lab. So this product is great for giving you some sort of utilization reports. You have a test center chassis that you recently bought, or the Axon chassis that you recently bought. It has got 16 ports. Well, are you utilizing all the ports in a way that you should be? How many of them are down all the time? Okay. And the other thing we get to the table is the capability of creating all these topologies graphically. And I'll show you a graphical editor that allows you to do that. Okay. Sound good? So very, very quick demo of the product. It's a classic resource management or lab management system, and we'll be aggressively improving the functionality of that over the next couple of months. But with that, I'm going to go straight to the demo. Sound good?
Excellent.
Excellent. Keep it short and sweet. Keep it focused.
Sweet, hammer to the demo.
Yeah, that's right.
Show me the real world.
That's right. If I can
I
just.
understand this correctly, this is very similar to what NetLab and Cisco Academy use currently, where they spin up sessions and drop them all the time. But this is it on steroids.
Pretty much,
Okay,
essentially,
cool.
yeah. Plus, it can cater all sorts of labs, right?
Yeah.
It doesn't space. You're not talking just to an NEMS. If you go to service provider, there are more complex labs.
Yeah.
If you go to these offshoring companies like the Wipros and the Tatas who are trying to build up center of excellences and trying to give out lab as a service functionality out, where you can actually rent a lab, this sort of product is great for them as well because they can monitor and allow people to reserve and schedule their lab.
Fantastic.
Yeah.
Measure ROI and interns that you don't have to have in your data center. the classic, pay an intern to recable it.
Yeah, that's right. We stopped hiring interns because we just get the interns to make coffee. That's it. So that's what mine is anyway. All right. So the product is a web-based system. So you do everything in the web. So here's a classic case of all of my resources in my lab. I don't have that many resources because I have a very small lab. So I'm a developer. But then you go to reservations. Quickly take a look at the calendar. It shows you graphically what's in my lab and what's blocked off, and you can reserve them. You can drag and drop. If you want to extend the reservation here a little bit, you can just drag and make it bigger. So it sort of gives you a quick overview of what's going to happen in the lab, who's blocked off the lab, and these are of course resources as well. And then of course you have topologies. So right now, a physical topology is essentially a graphical representation of what your entire lab looks like. And in the web, we show you a representation of what the lab looks like. So you see a whole bunch of routers, all connected together. You have a couple of switches, with sort of a lot of ports mapped to one another, right? So that's how your lab looks in real life. That's what the lab manager deals with. But you as a tester don't need to know that, right? Like I mentioned the example, your scenario is, I just need 2 routers, and let's bring them online. So that's the kind of scenario I'm going to take you through. That's what the tester will do. So we have a client-side graphical topology editing tool that we provide. If folks that saw my iTest demo in the last NFD day, this will be very, very familiar because we've plugged the topology right within iTest. So if you're using iTest to author and create your test cases, you can do the reservation and scheduling right from iTest. But you don't need iTest. This is a standalone product. What you're seeing here is a standalone topology editor that you can just use to create topologies. So, classic your palette for dragging and dropping. You have the bunch of resources that I have on my right. Here's what my lab looks like. I, as a tester, don't need to know what this lab looks like. So I'm going to close this. I don't need to know what this looks like. I'm holding up a test scenario in my hand, and the test scenario says I need to bring 2 routers online. That's all it says. So let's go ahead and do that. Okay. So I'm going to create a new topology. Let's call it NFD4 topology. Right? And we start off assuming you want to use everything in the lab, but most people don't. So I'm just going to select everything, delete, start from a clean slate. Okay? And my test scenario that I'm holding says I need to have 2 routers connected together. So I'm just going to drag the routers one by one, drag Cisco 1, drag Cisco 2, just going to connect them. That's it. Okay. Very, very simple topology. Create a test bed. Now I can keep dragging and dropping and creating my topologies, right? And now when I want to use it, I need to reserve it. If you'll notice, if I open up the, let's publish this draft first. If I open up the physical topology, if you go back to the one I created, I'm using Cisco 1 and Cisco 2 both connected together. If I go back to my lab, you'll see that they actually are connected through an MRV switch. Now in this case, they happen to be just the 2 things connected to the switch, but you could have lots of things connected to the switch. So before I actually make this topology online, what I need someone to do is map the ports together. And as a tester, again, I don't care how you have cabled in your lab. That's what I want. Let me go ahead and use this. Okay? So I, as a tester, have created this topology, but again, the product knows it goes through an MRV switch. So now as a tester, when I go back to my web interface, right, and I look at this topology, and I say, let me go ahead and reserve it. And let's, of course, I get a choice of doing a scheduled reservation or an immediate reservation. Let me do it right now, and let me block it for 15 minutes. Okay. It's actually going to go through a process of, if I can get my VM to come up, a process of activation. See, activation in progress. What this is doing is the product is going through figuring out how are the routers connected, making the right call to the MRV switch to map the 2 ports together and get the routers online. So now if we were to go back to the topology, you see the little green logo? It's active. As a tester, I didn't know what happened. The product figured out that, oh, you're going through an MRV switch, let me map the 2 ports together for you and make them online for you, right? So if you were to go back to the topology, it says successfully activated. If you go to the resources, it gives a list of all the resources you need. Again, it's hiding the whole fact that it went through an MRV switch. It's a layer of abstraction, which is great because how many testers actually know what's in the lab? Very few, right? See, they don't need to know.
Well, it's because the lab manager hates them all.
Exactly.
It's all his.
And everything is all in his domain. He hides everything from him. I don't want you, do not dare go into my lab. You can go into every single room in the building except for the lab. The key won't let you, right?
The lab manager will always keep it, he won't let you have it.
Exactly.
That's right.
Right. So this is one layer of abstraction where I actually dragged and dropped 2 routers. What's coming in the very next release is what we call abstract topologies. Here the assumption was I knew that I have 2 routers available. What if I don't even know that? What if all I know is I need 2 Cisco series routers and they could be anywhere in the world in one of my labs, right? So that's the next set of abstraction where instead of dragging a router at 10, 155, 23, I just drag a Cisco box, drag another Cisco box. And at runtime, this product will first convert it to logical topology, figure out, oh, you need this IP address, you need this router is available, you need this family, configure it with software, and then do the exact mappings MRV. So that's another layer of abstraction, what we call abstract topologies, which we are going to bring up very shortly. Yes, Angus.
I think it's worth noting that the standalone topology editor is connected to the server, so that inventory you see in the palette is just downloaded from the inventory listed in the server.
Yeah. Good point. Yes. I see nodding heads. Yeah.
Sorry, it wasn't quite clear. When you map the ports
Yes.
together,
Yes.
was the port selection abstracted, or did you specify specific ports on the DUT?
Right. So so the first thing is, let's create a physical topology, which is how my lab looks like in actuality, right? So if you look at this switch, you'll see that 1.1.1 ports connects to this server, 1.1.2 connects to this port, and I can actually specify that using properties. I can see what the source and destination are.
Understood. So that's
Right.
that's the lab provisioning.
That's the lab provisioning
But
part.
from the tester's perspective, on
Right.
on the other screen, on the topology,
Right.
for the DUTs, did they
Right.
specify exactly which port?
No,
or did you
because-
say any port between those two specific DUTs?
You can. Right now, the way I've set up these routers is that they just have one port each. So you can only drag and drop
Gotcha.
2 ports.
Okay.
But you can, in theory, drag and create multiple ports. And because you've actually represented how the ports are connected, the system underlying knows how the ports are connected. That's the point.
So one of the values of abstraction is that you get greater lab efficiency,
Greater lab efficiency.
but it also comes at a lack of specificity. So it works well if you get feedback to the user about which devices were instantiated or ports that were instantiated and given to them. How is that feedback given?
Correct. So the thing is, that makes sense only if you want to keep the abstraction level at the tester perspective. It's actually the other way around. In reality, the testers don't know what's in the lab. When they look at a scenario, all they're told is, I want this port connected to this device, connected to this port. That's all I want, and that's all they draw, right? To them,
Yes.
it's an abstract thing anyway.
Oh, absolutely. But
Yeah.
but they do need to deploy a configuration
Correct.
to the chosen DUT
Absolutely.
and make that specific to the chosen port.
Correct.
So it's good, but it works well if you get feedback and you use that to modify your configuration accordingly. I mean, I guess what I'm saying is, how do you give that
Right.
feedback to the user?
Right. So the way we do that is by something called drivers, right? So when you connect to the particular port, you're given the option of doing things to the resource. And
Okay.
it could be load a configuration, it could be do a mapping, and we allow the user to create their own drivers, right? Now, I have a driver that's loaded in a screen. You'll notice this driver is not binary. This driver is not C++ or Java. It's nothing other than an iTest test case. So if you have seen the iTest demo, you'll see that it's nothing than a series of steps that says, in the case of a map, if I can expand this, let me just connect to a particular MRV switch, map the 2 ports together, and then connect them. So you can create drivers that say on connect, do a load, or load this particular software configuration, or load a particular configuration, bring up some interfaces, shut down some interfaces, bring up this service if you want to. And you can do that at connection time. That's the flexibility you get.